nama saya SYAHIRAH RAIHANA binti SHUKRI, nombor matrik 044802 daripada KIM 4. Saya akan bercerita tentang pengenalan Introduction of Weather Station. Weather Station ni merupakan satu alat yang mengumpul data berkaitan dengan cuaca dan environment dengan menggunakan sensor. Weather Station ni dipanggil sebagai Weather Center, Personal Weather Station, Professional Weather Station, Home Weather Station, Weather Forecaster and Forecaster. Kami menggunakan ASP8266 Weather Station untuk projek ini bagi memudahkan serta menggunakan alat tambahan seperti Arduino, temperature sensor, light sensor dengan potential meter. Kami menjalankan projek ini di Surau Ar-Rawdah untuk mengukur temperature, humidity and light sensor, serta manual observation juga dijalankan dengan menggunakan handphone dan Arduino. Kedua-dua data ni kami bandingkan bagi memastikan kedua-duanya sama lah. So ada 3 fasa yang kami jalankan dalam projek ini. First kali embedded, second database, dan ketiga adalah data visualization. Kami memastikan data ni diupdate setiap dalam masa 2 saat. So more explanation will be updated by my friends about embedded database and data visualization and how we develop the ESP8266 now. Sekian, terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is AFIQAH binti Mazin, matric number 043526, and I'm from Bachelor of Internet Computing.
My name is NURUL NABILAH binti ALIAS, matric number 043689 from Bachelor of Internet Computing.
There are a few components that we use in our weather station. There are Arduino, breadboard, potentiometer, temperature sensor, resistor, LDR, wires, and node MCU. The first component is Arduino. The function of Arduino is segmenting code into function allows a programming to create modular pieces of code that perform a defined task and then return to area of code. The next component is breadboard. A breadboard is a device used a construction based in developing an electronic circuit. A breadboard is used for multiple functions to create a variety of products using electricity. The next component is potentiometer. The potentiometer gives us reading in the form of analog voltage from 0 to 1023. It can measure humidity and heat index. The output from the potentiometer is fed directly through the digital I/O pins of Arduino. The Arduino reads this output and calculates humidity and heat index. The next component is temperature sensors. The temperature sensors that we use has 3 terminals and required maximum of 5.5 volt supply. Temperature sensors directly connected to microprocessor input and thus capable of direct and reliable communication with microprocessors. The sensor unit can communicate effectively with low-cost processors without the need of AD converters.
The other component that we use in weather station is resistor. This resistor works on the principle of photoconductivity. When the light falls on its surface, then the material conductivity reduces and also the electrons in the valence band of device are excited to the conduction band. These photons in the incident light must have energy greater than the band gap of the semiconductor material. This makes the electrons to jump from the valence band to conduction. The other component is LDR. An LDR or light dependent resistor is also known as photoresistor. These resistors are often used in many circuits where it is required to sense the presence of light. These resistors have a variety of functions and resistance. For instance, when the LDR is in darkness, then it can be used to turn on a light or to turn off a light when it is in the light. Next is wires. Wires are components used with a breadboard to create a functioning circuit. The breadboard functions as a host for wire connection. Last but not least is Node MCU. The Node MCU is Node Microcontroller Unit. It's an open source software and hardware development environment that is built around a very inexpensive system on a chip called the ESP8266. The ESP8266, designed and manufactured by Expressive Systems, contains all crucial elements of the modern computer, which is CPU, RAM, Wi-Fi, and even a modern operating system and SDK.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya SYAHIRAH binti ROSLI 039850. Saya Suha binti KAMARUL BAHARI 040150.
Dan saya ATIKAH binti NURUL 040545.
Okey, kami akan menerangkan mengenai coding Arduino, interface dan juga database.
Okey, sekarang saya akan terangkan mengenai coding Arduino. Okey, first atas ni bagi tahu kita orang menggunakan ESP8266. Di sini adalah API untuk write key yang diberi oleh kita orang punya interface. Ini pula wifi yang kita orang gunakan dan juga password. Ini adalah server dia. Revolution untuk yang kita orang gunakan adalah 3.3. Di sini serial begin ni untuk keluarkan serial monitor lah. Yang bawah ni bagi tahu yang bahawa kita orang dah connect dengan wifi ataupun tak connect. Seterusnya kita orang akan tunjukkan untuk bahagian temperature. Ini untuk pengiraan temperature. Dan dia akan peringkanlah temperature tu berapa dan benda ni akan upload dekat bahagian database. Dan ni pula untuk bahagian humidity. Humidity ni akan bagi tahulah sama ada benda tu higher ataupun low. Dan dia juga akan samalah akan hantar ke kita orang punya database. Dan ini bahagian LDR nak bagi sama ada bagi tahu sama ada light tu bright ataupun dark.
Okey, sekarang saya akan sambung dengan interface. Untuk interface kita pakai ThinkSpeak. Firstly, kita akan create new channel dan akan connect dengan right key dan lepas tu kita akan create field ni contoh field ni lah untuk temperature, humidity dengan light. Untuk nanti bila database akan hantar dan akan keluar kat dalam ni dalam bentuk graf.
Okey, ni untuk bahagian database punya. Kalau kita tengok sini pada coding sini akan ada coding untuk temperature, coding untuk humidity, coding untuk light. Pada setiap coding temperature, humidity dan light tu akan ada serial print line di mana kat sini database ni akan dihantar ke ThinkSpeak. untuk setiap tu lah, humidity, light dengan temperature. Dan output pada database ni akan dihantar kepada ThinkSpeak punya tempat tu dan dia akan mengeluarkan graf lah.
The IoT is closer to be implemented than the average person would think. Most of necessary technological advance need for it to have already been made, and some manufacturer and agency have already begun implementing a small-scale version of it. The main reasons why it has not fully been implemented is the impact it will have on the legal, ethical, security, and social fields. Workers could potentially abuse it. Hackers could potentially access. Corporations may not want to share their data, and individual people may not like the complete absence of privacy. For these reasons, the IoT may very well be pushed back longer than it really needs to be. For example, in this IoT project, the system uses temperature, humidity, as well as rain sensor to monitor weather and provide live reporting of the weather statistics. The system constantly monitors temperature using temperature sensor, humidity using humidity sensor, and also for rain. The system constantly transmits the data, which processes the data and keeps on transmitting it to the online web server over a Wi-Fi connection. This data is live update to be built on the online server system. Thus, the IoT-based weather reporting system provides an efficient internet-based weather reporting system for users. Thank you.